This is Bob McFetrich with Beckwith Electric. I'd like to thank you for downloading our continuing training sessions on the M-6200A regulator control. This particular session will deal with both tap position and operations counter. Just to let you know, 4 out of 5 doctors have approved this session for a remedy if you're having trouble sleeping. So we're talking about tap position, and regulator controls typically do not require the tap position in order to regulate the voltage correctly. There is one exception to this rule, and that is for line regulators if you are backfeeding them due to sectionalizing or switching, and that application is covered in the reverse power session. But as a general rule, normally regulator controls don't require the tap position. But they can monitor the tap position, and in doing so, it's not a physical linkage. So there's no linkage, either cable or voltage reading or anything, between the actual mechanism and the control. But basically what happens is when you install the control, you tell it what tap position the regulator is currently on, and then it'll monitor either the operations counter or the motor sealing input for a Cooper regulator. And when it sees the operation counter increment, it knows the regulator just tapped. So it'll look to see which of the two motors were active, either the raise or lower motor. And depending on whichever motor was active, that's the motor that will actually, that's the direction that the tap position will be incremented. So for instance, if I were on 3 raise and I saw the operation counter increment, I would look at the lower and the raise motor, determine that the raise motor was active, and therefore go from 3 raise to 4 raise. And if the control does lose power, the tap position is stored in non-volatile E2-prom, so when it powers back up, it remembers the tap position it was on when it last lost power. And as an added security, every time the regulator goes through neutral position, we should see the neutral light indicator come on, which is a separate physical input from the reversing switch, and that drives the neutral light on the panel. So if we see that neutral light come on and the panel does not believe it's in neutral, it will automatically recalibrate itself to neutral. So if I was at -3 or 3 lower and we tap and we see the neutral light come on, I will go from 3 lower to 2 lower, but then as soon as I see the neutral light come on, I'll immediately go to neutral position. So with that in mind, there's several things we need to look at from a configuration standpoint, and all the configurations we're going to be looking are under the tap settings section of the software. And the first one is the tap information. For keep track to work, we have to enable it. So there's only 2 options in this list box, either disable or regulator keep track, and that's what we're going to select. Once we do that, then we have to tell it what type of operation counter to look for. And there's 2 phases to that. One is whether to look for the operation counter to come in the operation counter input or to come in the motor sealing input. And then once you determine which physical input to look at, you need to interpret when the voltages change, how that's interpreted. So let's look at a couple things here. This is the 2 terminal blocks on the regulator control, and you can see right off the bat that from a physical standpoint, for Cooper regulators, instead of looking at the operation counter input to determine whether the regulator tapped, we're going to look at the motor sealing input, which is on TB25, and we need to have a jumper from TB21 to TB22. So for a Cooper regulator, for it to tap and to keep track of tap position, I'll monitor the motor sealing, and when I see activity on it, I will see whether the raise or lower outputs were energized and then increment or decrement accordingly. And I need this jumper from TB1 to 2. For all other regulator manufacturers, they do not have a motor sealing input. The operations counter will actually be coming in the operations counter input. And so I would look for that input. And I would need to remove the jumper from 1 to 2 on TB2 and replace it, move it to 2 to 5. So, from a physical standpoint, for the operation counter to work and therefore the tap position to work, for a Cooper regulator, I need to have a jumper from TB2 1 to 2, and I need to be monitoring TB2 5, the motor seal-in. For all other regulators, I'm going to be looking at TB113, the operation counter input, to determine if it's tapped, and I need a jumper from TB2 2 to TB2 5. And then I will look for a voltage on either one of these outputs to determine the direction. And that will be referenced from motor power. So in the 6200A, we have what's referred to as a zero voltage circuit. And what it does is it uses the motor power as the reference and looks for a voltage between either 5 or 6. And you can do the same thing with your meter. If you were to take your meter and you put one end on TB19, which is the motor power, and the other one on 5 and 6, what you would find is normally they would read 120 volts AC because neither one of them is active. But when one of them becomes active, that particular output will go to 0 volts, and the other one should, if anything, go up in voltage. So, for instance, if I were doing a raise, I would expect the voltage from TB19 to TB15 to go to 0, and on 6 I would expect it to go slightly higher, if anything. And so that's how the keep track basically works, is we look at either the operation counter or the motor seal-in. When we see that an operation has occurred, we're then going to see which of the two outputs is low in reference to motor power, and that is the way we're going to tap. So with that in mind, the one setting that is unique to each different vendor is our X1, X2 motor seal-in setting. And that is set by each vendor. If you go from our main screen at the very beginning of the configuration, select the regulator manufacturer. And that's a new feature we've added to this version of firmware. It used to be that you had to know how to set this particular setting yourself. Now it's one of the settings that does get pre-configured if you select a regulator manufacturer. So for instance, if you were to select GE, it would automatically select X1 for this setting. And what X1 says is, I need to go from a high to a low back to a high for one tap. So for GE, if I were to take a meter and go from return, which is 10 right here, to 30 TB or NN30, which would be over here, the op counter, what I would see is normally I would see 120 volts. But as it was tapping, it would momentarily go down and right back again. So in the quiescent mode, when it's not tapping, I'm going to read 120 volts. But as it's tapping, the contact will break up and make again, and I'll see that voltage go away and come right back. And another way of looking at that would be here. Again, NN30 would be here. And we follow it back to TB113, which is the op counter input. So we can do the same thing. If we go from the op counter, the return, which is TB18, to TB113 with our meter, we should see voltage present, but as it's tapping, it'll quickly go away and come right back again. And again, we notice since this is a GE, we need to have the jumper from 2 to 5 on TB2. Now, for Siemens and Howard, we would select X2. What X2 does is basically it expects a transition per tap. So, for instance, the odd taps will read no voltage, the even taps will read voltage. So, while I'm on the even tap, I might expect to see voltage all the time, the odd taps never. So we're GE in the quiescent mode, you're always going to read voltage. For the Howard and the Siemens, you'll always read voltage on one tap, but then on the next you won't read voltage. And on the next, you'll read voltage again. So therefore, an on-off-on for GE is one tap, but an on-off-on for a Howard or a Siemens would actually indicate 2 taps. And for a Siemens, we would be looking at the PDS plug, same with the Howard. is where we would be measuring. And if we look here on a Siemens, the op counter is on U10 of the plug going to TB113, and the neutral would be on E. So if we take a meter and go from E to U10, on one tap we should not read any voltage, on the next tap we should read voltage, and then on the tap after that, not read voltage again. And again, we would have our jumper between 2 and 5 on TB2. Now, there has been a potential problem we have seen with some Siemens regulators, especially if they've been reworked in a regulator shop, and that sometimes their motor that runs the raise and the lower drive can be wired with the polarity backwards. So typically what we would expect to see, if I got a meter and I went from motor power, which would be U2, to either the raise or the lower, J and K, I should read voltage, but if I'm not tapping. But this say we're doing a lower. If I were doing a lower, I should see no voltage between U2 and K, and the voltage from U2 to J will actually go up from 120 to around 170. But if the polarity is reversed, instead of that voltage going up, it'll actually go down. And on the M-6200, the zero crossing or the 0 volt detection is actually defined to be any voltage below about 85 volts. So if that 120 goes down below 85, even though the lower is at 0 and the raise may be at 70, the control would interpret both of those as being active, and if it sees both of them active at the same time, it will tap towards what it thinks is neutral. So for instance, if I were on 2 raise and I issued a raise, and instead of going to 3 raise, the tap went to 1 raise, that would be an indication that this phenomenon was going on, and to prove it, I could take a meter out and measure it. And if that is indeed the case, then the motor on your regulator has the wrong polarity wired to it. And this is a similar on the Howard. Again, for the Howard, the jumper is still 2 to 5. On the plug, it's the same notation. It's just they use different notation, but it's the same wiring. So, for instance, they use DHR for drag hand reset, but the ones we're concerned with, MS for motor power, L and R for raise and lower, and OC for operation counter. So if I go from ground to operation counter, I should again see voltage on one tap, no voltage on the next, voltage again on the next. And then if I were to look at the raise and the lower in reference to motor power, which would be MS to either L or R, I should see voltage unless one of them is tapping, and then that one should have no voltage, and the other one, if anything, should have a higher voltage. So that covers the GE, Siemens, and Howard, but Cooper's a little bit different. With the Cooper regulator, it has a sealing circuit. We talked a little bit about this on our session on blocking. But basically, Cooper is the only regulator where the output contacts are driving the motor or the regulator directly. For the others, they're typically charging a spring, and then when the spring is fully charged and it operates, that's what actually provides the torque to move the contacts from one tap to another. But if you're going to be on the motor and driving the motor to do that rotation, you want to guarantee that once you start, you're going to complete a tap. You don't want to be stuck in the middle of a tap. And so what the Cooper regulators do is they have what is known as a sealing contact. So when the regulator control does a raise or a lower, that output starts the motor, which then starts rotating the shaft, but actually after it starts rotating, a contact on that picks up and seals the motor up for the completion of the tap to guarantee that you don't get stuck in between taps. So that input, that motor sealing contact, is the trigger for the operation counter as opposed to the operation counter. So for a Cooper, I would select motor sealing down here. So for GE, we'd be looking X1. Howard and Siemens, we'd be looking at X2. But for Cooper, we'd be looking at motor sealing. And once we select that, we can then enable this lockout or this block alarm. And what that does is, if that seal-in contact, and there are two seal-in contacts on the regulator, one for the raise motor and one for the lower. But if that contact were to stop operating, you could still tap the regulator, but we're first of all not going to have any op counters or tap position. And secondly, we can get the regulator stuck in between taps. So it's advisable when you see that you're not getting that motor seal-in feedback loop, it's advisable to block an alarm. And that's what we would do if we were to select that off. If we disable it, we can still alarm, we just wouldn't block operation. So for the motor seal-in, there are two types of Cooper harnesses. The older fan strip, which is this one right here, or the newer gray Phoenix connector, which is this one right here. But in either case, you can see that it's functionally going to be the same. We do have to move the jumper to TB2, 1, and 2. And now we'll notice that the holding switch, which is actually the op counter, comes in on TB2, 5. So if I were to take from ground to TB25, from 8 to TB25, that's where I would see whether the op counter, the holding switch, was coming in. And it behaves very similar to the X1 of the GE, where you've got voltage and it very quickly goes away and comes back again. So you're looking for a transition. And this is the physical. So again, there would be your neutral light, which again is used to reset if we get off. You raise, your lower, your motor voltage, and your holding switch is your operation counter. And it would be the same thing over here on this terminal block for the newer Cooper panels. So that basically defines how the tap position is going to operate. Now, there are ways it cannot operate, and look at those from a troubleshooting standpoint. The first is if I have a panel where I'm never getting an op counter or the tap position to change. That is an indication that I either have motor seal-in selected on a non-Cooper regulator, or I have either X1 or X2 selected on a Cooper regulator. So remember that the panel will look at either the operation counter input or the motor seal-in input as the trigger to indicate an operation. And so if you've got it programmed to look at the wrong input, that input will never change, and therefore you'll never get an op count. Now, if I'm getting an op count and it's wrong, but it's consistently wrong, it's probably got something to do with the X1, X2 setting. I've got set X1 on a Siemens or Howard, or X2 on a GE. So on a Siemens or Howard, it's only changing once per tap, from open to close. So if I set that to an X1, it's going to have 2 taps before it does one complete transition, and therefore I'm only going to count every other tap. If I set X2 on a GE, then it's going to see a full transition, but think that that's 2 taps, and I'll count 2 taps for every tap. So if I'm counting twice as many as I should, you're set to X2 when you should be set to X1. And if I'm only counting half of what I should, then you're in the opposite mode. But if all that is set correctly and we're still getting off, it's probably due to contact chatter or debounce. And so what we have there with contact chatter or debounce is you can have a dirty or noisy operation counter within the regulator. And so when it changes state, instead of just going from on to off, it may bounce a couple times before it settles into off. Well, if I see it toggle 3 times and the raise output is up for all 3, the panel will interpret that as 3 raises and 3 operations, and now our op counter's got more operations than it should, and our tap position is off. So to fix that, what we would do is we would go in and enable this count window, and as soon as we do that, this will be on grade, and we can enter a time in here. And the time we're going to enter is the amount of time it takes the regulator to physically tap. And what you're telling the control is whether I see one operation counter or 20 in that time period, it's physically impossible for the regulator to do more than one tap during that period. So only increment the op counter by 1 and only change the tap by 1. And with that, you should have your panel back with the correct tap position. Now, a new feature we've added is accumulation of current. So for each tap position, we have had traditionally a bar graph where we count and accumulate the number of times it's been on each tap. But now we've also added to that the amount of current that was broken as it leaves each tap. So you'll get an accumulated wear to help better determine the wear on any contact for any given tap. With an existing panel, and the existing panel already had, say, 22,340 counts on it, we would want our panel to start at that point so that our monthly reads would continue to make sense. And so you can preset the value there, or you can do it via the front HMI of the control. Likewise, when we install a panel, it's going to assume it's on neutral. If it's not on neutral, let's say it's at 12 lower, what I would want to do is come in here and put a -12, hit yes, and then save, and it'll preset the tap position then to 12 lower. And again, that can also be done via the front panel. So, new features we've added is again the wear. So the wear is the amount of current we're interrupting, and then the percentage of that total on any given tap. And we can alarm with that. We can also increment the number of times we've gone through neutral, and this predictive maintenance alarm is actually a backwards counting operations counter. So if I were to preset that to 10,000, it would count backwards on each operation, and when it gets to 0, it will generate an alarm saying it's time to do maintenance on the regulator. We can also reset both the predictive maintenance alarm, and we can reset the drag can resets via the screen. So now we've got a little better understanding of both operation counter and tap position. We're going to conclude this session by looking at some of the DMP points that are available to monitor these things. And we're going to start with binary inputs, and we can see neutral tap is our neutral switch indication to indicate the neutral light's on. We've got blocks on tap. We can keep track. These keep tracks tell you when it thinks it took a tap or not. So for instance, I can send out a command to raise at a tap, and then I can verify that the keep track toggled in the same direction that I was going. We also have an abnormal tap alarm. Now the abnormal tap alarm is set by a couple different things. Number one, if I see the neutral light come on and I was not in neutral, I know that my tap was off. Number two, if I think I'm in neutral but I don't see the neutral light on, that's an indication the tap may be off. And finally, if I don't have blocking of limits enabled, if I reach a limit, to say I reach 16 rays, but then the rays increment, the next rays increments the op counter again, that's an indication that I really wasn't at 16 rays, and therefore my tap may be off. So those are some of the things that can generate the abnormal tap alarm. And you can see we've also added a new point for the individual tap wear alarm for the summation of current. From a binary output standpoint, we can reset the resettable counter. Now there are two operation counters in the control. The counter we've talked about so far has just been the normal counter, which you can preset but you cannot reset. There's a second counter that also gets incremented that is a resettable counter. So for instance, if you want to do monthly reads, you can reset them once a month, and prior to resetting, if you look at the value, that will tell you the value of the prior month. From an analog standpoint, analog output standpoint, those are all the settings, and we've gone through many of these settings already. The min and max taps and the blocking and the regular operation counter, the neutral counter, tap position. You can calibrate the tap from here. So if somebody locally tells you it's on 7 and you're reading it at 8 rays, you can remotely send a command to change it to 7 rays right here. And so these are some of the analog outputs you can change. And finally, for analog inputs, we can monitor the tap position, the drag hands, the op counter, the resettable op counter, the neutral counter, and then the limit, the count limit. So hopefully this has been a helpful session and going through and figuring out how we can determine what tap we're on, and also how to update the operation counter, and also give you a little bit of troubleshooting if things aren't working correctly. As always, if you have any questions, comments, concerns, you can submit them via the web portal. And if not, we hope this material was valuable to you. We value your time in putting into this, and we hope you have a blessed day. Thank you. Bye-bye.